My name is Irini Papadaki and I'm from here in Thessaloniki, where the FENS Future Regional Meeting takes place this year. I absolutely love my city and it has been point of inspiration for me. When everything is turbulent, I go down to the 12 kilometers of sea promenade, and under the installation of these umbrellas that they have transformed into somata of neurons in the program of the conference, I am back to point zero and I restart. There was an absolutely huge and amazing coincidence how they decided to do the regional meeting of my field of science, which is neuroscience, in my own city, and then having a Nobel laureate from 2014 attending and giving a talk. So I'm delighted to welcome Professor John O'Keefe, Nobel laureate in medicine and physiology in 2014, for his extraordinary discovery of neurons activated by particular locations in the outer environment of the rats, a process that creates a spatial mapping in the brain. Professor O'Keefe is currently affiliated to the University College of London, where he has remained since the days of his postdoc, but nevertheless his endeavors took him in many places before that. So, Professor O'Keefe, can you please give us some information about your academic life story, the different scientific fields you have explored and your escalation in the academic hierarchy?
So I'm one of these people who took quite a bit of time when I was young to decide exactly what I wanted to study. I actually started in secondary school doing classic studies. I studied Latin and Greek ancient history and things like that. But I found that I wasn't very good at that. And so after high school, I actually wasn't able to get into college. And so I had to go out and work. So after secondary school, I actually went out to work, and I worked in various jobs. I worked in the stock exchange, I worked in an insurance company. But eventually I decided that I wanted to go back to school and study again. And I decided to go and do something very different from what I had done in secondary school, and actually study engineering, and specifically aeronautical engineering. You have to remember this is now 1950s. It was the era of Sputnik. There was a lot of money going into space exploration and aeronautics, and it was a very attractive field. So I went and worked in the daytime and studied aeronautical engineering in the evening. And I did that for several years, eventually ending up as an engineer at an aircraft company on Long Island. I was at that time living in New York City. But after doing that for a couple of years, I decided that I would then go back to full-time studies. And I was very lucky that there was at that time the only university in the United States where you could go and study in the daytime full-time for free. Every place else, and even when I was going to study in the evening, I was paying quite a lot of money for tuition. So I went back and I enjoyed it tremendously. I studied physics, I studied English, I studied filmmaking, I did a lot of things. And I did a lot of philosophy and a lot of psychology. And I realized that a lot of the questions, the eternal questions that philosophers were interested in, what is the mind, what is consciousness, is there a soul, all of these sorts of things, actually were probably going to be answerable and addressable if one studied the brain. And with the techniques that were just becoming available, that was going to be something that was possible in the immediate future. So I started to concentrate my interests on studying the brain, and at that time there was no field called neuroscience. There were almost no courses where you could study the brain. There was a basic course in the anatomy of the human brain, but very, very little in addition to that. And then after a couple of years, I had to graduate, so I then had to go and find out what I was going to do for the rest of my life. I was very lucky to get a position at McGill University, which was one of the 2 or 3 universities at that time where you could study brain research. So that's what I did, and after that I then came to London, came to Europe, and that's where I've stayed for my whole career.
Great then. So, based on all this fascinating transition from one field to another, but in a collective manner, I would like to ask you if you think that there is that we need to give some consideration into constructing schemes which would allow scientists to keep producing while still learning and expanding their horizons in an interdisciplinary manner. Maybe even programs that would be paid so we can give them some financial security.
Well, I think that's a very important question. It certainly is true that I was very fortunate that since I had a background as an engineer, I was able to use and exploit some of the developments in electrical engineering right at the early stages of my career to enable me to, for example, design and build amplifiers which would enable us to record from single cells in freely moving animals. Something that was really almost not done prior to our work and the work of a small number of other laboratories at the time. So I'm a great believer in the idea that neuroscience in particular, science in general, but neuroscience in particular, does rely on bringing several disciplines together and using the strengths of each of those disciplines to answer questions which each one couldn't actually address or answer by themselves. I think it's a very good idea that people, even though they're established and are very successful in research, continue to develop new techniques, keep their ideas alive. Right now, our laboratory is involved in trying to develop some of these new techniques ourselves. Some of my students are using microscopes to do two-photon imaging studies, which will enable us to record from hundreds of cells at the same time, where you can see the cells anatomically, but also see when they become active using calcium images. And we're also involved in using silicone technology to design and build, this is in collaboration with many other institutes, to build recording devices which will enable us to record from thousands of cells at the same time. So I'm a great believer in continuing to develop technologies, and I think it's an important part of science in general, but neuroscience in particular. And we're very fortunate that many of these technologies are being brought into neuroscience from other fields. We have a lot of interest from physicists, chemists, mathematicians now. It's a great time to be a neuroscientist.
Yeah, I agree with you actually. Nevertheless, currently there is a generalized state of restlessness in Europe, including the UK, about the potential funding cuts. And recently the EU asked 220 million from the European Research Council, and the UK government is thinking of cutting about 25 to 40% of its budget for science, according to The Guardian. Do you think we can do something to ring-fence funding? And do you think we should turn more towards funding from pharmaceutical companies?
So I don't know the articles that you're referring to. I haven't seen that yet. In general, my impression was that the conservative government of the day is very supportive of science, and they have tried to maintain budgets. I know that budgets are under threat in Europe. It's obviously, these are difficult times in Europe in terms of funding, and we obviously do what we can to maintain the science budget. It's of course easy to cut science funding because you don't see the effects for many years, but it's probably not a good long-term strategy, because in reality our future industries, our future wealth will eventually come from the money that is put into science and technology today. So yes, I think we really should try to make the case that science funding should be preserved where it can.
So this follows my previous questions. There is a notion of publish or perish in the academic world, and we are all impressed by that. It seems like at the moment for being a scientist one needs to pay a price, like it's a punishment, or to be extremely good. Do you think that if by providing more security or even more positions, because in many jobs there are people that are great and people that are mediocre, it's just the choice of life and what they do, researchers would be a bit more reluctant to experiment more, to take a step back and see, to have a long shot, because to me it feels that many application grants seem a bit conservative or non-innovative. They just take a very small step just to secure the funding.
Yeah, it's true that the pressure on all of us, particularly the younger scientists, to publish in high-impact journals is increasing all the time. I mean, part of the problem is that neuroscience is such an attractive field that there are huge numbers of people who want to be in the field, and there's not much we can do to expand the number of positions, certainly in the short run. So that does put a lot of pressure, and it puts a lot of pressure on people very early in their careers. And I have no doubt that that's a major influence. My own feeling is that it's better to concentrate on important topics, try to understand the topic, take the time to do that, even if it takes several years. And that's one of the things I'm trying to do in this new institute, is give people the freedom to explore, to make mistakes. Science is the art of making good mistakes, and then making better mistakes the next time. But in the end, we live in a real world, and when one is judging one's peers or people who are newly coming into the field, there's nothing as comforting as having a paper in a high-impact journal. So I'm aware of the pressure, and there's a limit to how much one can mitigate that pressure. It's always nice to see that somebody has produced a nice piece of work and gone to the trouble to write it up properly and get it published. So being realistic, I think the best we can hope for is to reduce the number of publications, go back to the way things used to be in the good old days, when what was expected was a long paper which would explore a topic, which would explore an issue, and that you got a lot of credit for that, and not the salami slicing technique we have today, where you try and get as many papers as you can from any piece of work. So I'm certainly sympathetic to that, but on the other hand, there is a real world out there, and we have to sort of, if people are giving us a lot of money to do this research, and I think they like to see that we are using it wisely.
And with that, I would very much like to ask you about the notorious human brain project. What do you think about it?
I'm not going to pass on that. So this is really, yes, that's very political, and it certainly is one of the projects. There are several of them now, including the, I guess we call it the Obama project, where governments are realizing, and usually, including supranational governments, are realizing that progress in the study of the brain is going to require considerable resources. Many of the techniques that are coming online now are really, really expensive. We need big computers and things like that. So there are several of these, but I'd rather not talk about the relative merits of these.
Okay. This is a very simpler question than everything I asked. How much do you think a self-funded student should control the affairs of his or her research, and how much the supervisor should do?
A self-funded student?
Yes, I mean a student that probably has taken a scholarship from one of the funding bodies, but not necessarily under a grant of his or her.
Ah, right. So okay. So that's what it is. So I was going to say all of our students come with money either that we provide them with, or that, as you say, they get scholarships and fellowships. There is a tendency these days to try to give as much as possible the money to the students, and that then make the choice. So you try to identify good students, give them the money, and by money I just mean tuition and things like that, and then let them choose the supervisors. My own feeling is that the students are the lifeblood of the system, and I try to give them as much freedom as possible. I know other supervisors are a little bit more restricted. I quite often give a student, when they first come in, a set project just that they can learn the techniques and things like that. But then, if they show the drive and the creativity, I try very much to sort of give them as much freedom as possible. Sometimes that doesn't work. They spend 2 or 3 years on projects which don't work, but when it does work, it's incredibly beneficial. And I think the early years are the time of most creativity, when people actually can come up with very different attitudes, very different approaches to the problems. So I tend not to be too directive. I probably err too much on that side. I understand why, if you have a grant and you promise to do a certain amount of work, there's a great temptation to actually try to get the student to do that. But in general, I try to give them a bit more freedom than you would expect in those circumstances.
I see. Well, I will quote now from a guy in the internet, this very amazing citation, from a webpage called Academia, where we all share our troubles. So, this person wrote that a professor told me that publication is about intelligent copy-paste from one field to another. So, I personally, and without praising myself for a spectacular background in maths, have been startled sometimes by the misuse of statistics in neuroscience, the wrong use of statistics. Do you think that we would all, the experimental neuroscientists, we would require some more in-depth knowledge in statistics and probably coding? The first one to help us do better analysis and interpretation of the literature, and the latter for analyzing the results more quickly?
Well, I have no doubt. I mean, that statistical analysis of results is important. And of course, I, for my sins, have read much of the literature of the 1930s and 1940s, for example, in rats running in mazes, before there were any statistical analysis of the results. And there was somebody like Carl Lashley, one of the great giants of animal learning research. He would just show you all the raw data and say, there it is. It's obvious there's an effect here. And so the introduction of statistics has been very important in some ways, but probably not in other ways, in the sense that I certainly like to concentrate on research which gets really big effects. So if a student comes along and says, well, I've got something and it's just significant at the 0.05 level, I think maybe tomorrow it'll be at the 0.06 level, or yesterday was the 0.04 level. And I would much prefer results, especially when one is first examining a problem, where if you did the statistics, it's at the 0.001 level or something like that, so that it's so far away from any borderline that you're pretty confident that it's going to be repeatable. One of my colleagues, who will be nameless, used to say, well, I can tell something is significant at the 0.05 level if I can see the difference between the curves at 5 meters, and it's at the 0.01 level if I can see the difference between the curves at 10 meters, and things like that. And what I think he was saying is that, yes, we need to use statistics, and we used to have this very strong sense of statistical thinking, but that for many of the things we're interested in, especially at the early stages of our studies, you really should be looking for very, very, very big effects. As I put it in the book that Nadell and I wrote a long time ago, at this stage we're looking for the mountains and not the molehills. There's plenty of time later on to look for the subtle differences and the subtle effects. In the beginning you should be looking for the big, big effects. And quite often one finds big effects if you take that approach. So yes, the answer is yes. The more mathematics you know, the better you are. But I think one has to use that approach very, very carefully. And much of the criticism of say, the field of psychology that's been bandied about recently is the non-repeatability of studies which rely very heavily on statistical differences, and which then, as you'd expect, by chance when you repeat them, some of them are not replicable.
So I'd like to now move to this other side of Europe, the east side. And as we don't have much time, and since the conference takes place in Thessaloniki, I will concentrate in Greece. I'll give you a couple of statistics that you probably don't know, obviously, about it, to then relate it to your work as a young student, once upon a time. So, here there was to be a tradition where everyone had to attend university, even if they were bad students or they knew they would take over the jobs of their parents later, they still had to do it. It was related with social prestige. And on top of that, the university, the bachelor degrees in Greece are free. So education kind of follows an idealistic way of being transmitted, that knowledge needs to be given to new people and shape up brains and personalities. The problem is that the curriculum, for example, of BSc in biology here in Aristotle University, consists of 52 modules, but even with all this, there are no jobs out of uni, and there are no research jobs in uni. And recently Greece lost access to bioinformatics journal, and Elsevier and Springer are also threatening to cut their research. So there are three interesting statistics I would like to share with you. 3% of the whole population has now emigrated. And 12% of this population that emigrated hold graduate degrees. That accounts for 130,000 people. There is almost zero funding from the government, but there is a surprising fact that 3% of the world-class researchers are Greek, while the population is 0.15 of the world's population. And based on this proportion of population to internationally renowned research, that ranked Greece as 13th in the world. But here comes the sad truth. 95% of the research of these Greek people, either affiliated with Greek universities or affiliated with other places, have been conducted in foreign countries. That effectively has led to this brain drain, as it has been talked recently. So there are not enough brains left here for conducting research in brains. So based on everything you have experienced these 40 years, and out of being one of the founders of the British Neuroscience Association, which is currently the strongest in Europe, what do you think we should do collectively or individually? Can we somehow shape the future of science and neuroscience in particular?
So I don't think you should lose heart. I mean, hopefully the situation, the current situation in Greece and in Southern Europe is a temporary one. I'm a great believer in Europe in general, partly because I think it provides a partial solution to this dilemma, which is people feeling they need to leave their country. If Europe works, then what I think we can expect is that people will leave and work in other countries in Europe or in other countries outside of Europe. But then as the economic situation begins to improve, I think that they will then come back. And we've seen that in other countries as well, where scientists found that they had to leave for usually economic reasons. But then, as the economy improved, they started to come back. So I think what we can expect is that as the economic situation improves, and we're all hoping that it will improve, that more jobs will become available for these people who have had to leave, and that one should see it, if possible, as just a temporary situation. On the other hand, I think Greece should be proud that it has such a good track record in producing scientists, and science is an international phenomenon. Many of the products of science benefit all of us, not only the people in the countries where the science is done, but in other countries as well. So I think we should be very proud of that. And let's hope that this is just a temporary setback, that things will improve and Europe will get back on its feet.
So I have 3 last questions, but they are much shorter than everything before. That follows a bit what I just asked you. How did you find this regional meeting, and why did you decide to support it? Because yesterday in your plenary talk, you mentioned that you turned down many other invitations for...
Yes, so as I said then, I received many invitations to give plenary lectures all over the world, and in general it's just not possible to even begin to think of satisfying more than a very small percentage of it. So I'm very selective. On the other hand, I have lived in Europe. I grew up, of course, in the United States and New York, but I've lived most of my life in Europe. I'm a very strong, committed European. I believe in the idea of Europe, and I believe in the idea of FENS. I'm a great supporter of FENS. So when I was asked to come here, I actually didn't hesitate. I thought this would be a very, very important meeting. Not least because I think the idea of forming these small regional subdivisions of FENS is a very important one. Sometimes these big meetings where we go and there are tens of thousands of other neuroscience scientists are overwhelming. They're just, I remember going around when I was a younger scientist, having a good idea and going around looking posters, and about 10 other people had the same idea, and I knew they were going to have it done before I... So it was, if anything, a bit depressing. But I think these smaller meetings, especially where people are from a region and can see ways in which in the future they can collaborate, pool resources, have exchanges between their laboratories, are a very important way of beginning to build the infrastructure that we need to go forward in neuroscience in Europe. So I thought it was a great idea, and I wanted to come and help and share in the excitement of 3 different neuroscience societies. So I'm very glad to be here. Yeah, it's terrific.
That's great then. And now I want to make you one last personal question. You're still very active academically and scientifically. But after having received a Nobel Prize and having all these years on your shoulders of research, do you feel fulfilled? Do you feel peaceful by the knowledge you have accumulated and delivered?
Actually, it's the direct opposite. I think in some ways you become more vulnerable. Yes, I think, I feel motivated to keep going. I get enormous pleasure out of going into the laboratory. I love doing experiments myself, and
that's great.
It's not a very well kept secret, but quite often at 6 o'clock at night when other people are going home, I actually sneak into the laboratory and do some of my own experiments by my own self. So, and I will continue to do that until I can't do it anymore, and then I will just walk off into the sunset. So no, it's if anything, it's obviously it's a great honor, and it's nice to have your work rewarded and a whole field rewarded, because of course, they gave the prize to myself and the Mosers, but of course we represent a huge number of people, neuroscientists, who are all working on the hippocampus. So I'm quite pleased that we got it. It's taken quite a bit of work if it's just having to deal with all these requests. But no, I continue to be an active scientist, and I hope I will continue to be an active scientist for as long as I can. And then I'll go off and do what you say.
Του πω άλλη μία ερώτηση, γιατί είναι 3 παρά 2-3. So almost 3 o'clock.
So you see the future of neuroscience hopeful? Do you?
Yes, so I think it's a very exciting time in neuroscience, and I'm really tickled to be still playing the game. we know that many of the questions about how parts of the brain work, how they interact with each other, will only be solved when we can do things like record from and watch the activity of large numbers of cells and how they interact with each other. We're pretty sure that things like thoughts and feelings and all the things that we think are important products of the brain are happening at this network level. So the fact that we are now just beginning to get, after all these years, the techniques for being to record and study these processes is really very exciting. Up until now, we've been able to look at single cells, we've been able to look at whole areas of the brain using imaging techniques. But that intermediate level, where you look at how lots of cells are interacting with each other, has really not been possible to study up until now. So I think it's a great time, and I think you're lucky to be coming into this field.
I think so too.
And I'm very excited about the next 5 or 10 years.
And my final is a completely irrelevant question. I don't even know if I'll include that, but since I have you in my beloved city, where I grew up and all this motivation for science was created within me, how did you find it during your brief stay?
Well, so unfortunately, they've been working me very hard. It's been raining, and so I'm looking forward to getting a bit of time, either to this afternoon, aside from the basketball game, or tomorrow morning before I leave to walking around the city and seeing. But what I've seen so far, of course, the bay and everything is really obviously
you
very,
should walk
very
in
nice.
the promenade, it's 12
Yes.
kilometers.
I have walked a little bit. I have been up and down the promenade in the rain. I gather it's very uncharacteristic for it to rain this time. But I look forward to it, and yes, I know that this is the cradle of many aspects of our civilization. I'm very glad to be here.
Well, Greece may has once been the cradle of civilization, but what is great in humanity, what I find is great, is how humanity can add throughout the centuries more knowledge and more culture that causes a reprise of awe towards this creature, the human. And what I wonder is this organ that makes him do all these amazing things, the brain. So in my own micro world, it's a wonder to be drinking tea in a favorite spot of superb view, you should admit. In the company of a marvelous brain as yours, and a warm smile. You're smiling a lot. So it's been my honor. Thank you very much for giving me.
Thank you very much, and thank you for inviting me.